In this video, I want to begin working on the Chapter 2 sample test, beginning with question number 1. F prime of a is equal to limit as h approaches 0 of f of a plus h minus f of a over h. In the Larson book, this formula is slightly different. In the Larson book, it will be written as f prime of a is equal to the limit as delta x, instead of h, they're using delta x, approaches 0 of f of a plus delta x minus f of a and all over delta x. So that's the form of this limit definition of the derivative that we'll use here. And we want to use that to find the derivative of f of x is equal to 3 minus x squared for a is equal to negative 1. And so what we're looking for here is f prime of negative 1, and that will equal the limit as delta x approaches 0 of f of negative 1 plus delta x minus f of negative 1 all over delta x. So the first thing that we want to do is take the function f of x and plug in negative 1 plus delta x wherever we see x. So we have the limit as delta x approaches 0 of 3 minus negative 1 plus delta x, quantity squared, then minus f of negative 1. Well, if we plug negative 1 into 3 minus x squared, we're going to get 3 minus negative 1 squared, 3 minus 1, which is just 2. And again, that's all over delta x. Next, we can subtract the 3 minus the 2, and we have limit as delta x approaches 0. 3 minus 2 is 1 minus quantity negative 1 plus delta x squared all over delta x. If we multiply out the negative 1 plus delta x, we would get limit as delta x approaches 0 of 1 minus quantity 1, then negative 1 times delta x is negative delta x, double that is minus 2 delta x plus delta x squared. Again, all over delta x. Now, when we simplify this, we'll have limit as delta x approaches 0. 1 minus 1 goes away. Negative or minus negative 2 delta x becomes 2 delta x, and then we'd have minus positive delta x squared or minus delta x squared over delta x. We can cancel delta x's and we'll end up with limit as delta x approaches 0. We'll factor out that delta x in the numerator. 2 minus delta x all over delta x. We cancel the delta x factors, plug in delta x equals 0, and we end up with the limit is equal to 2. Now then we'll scroll down and look at the next problem. Here we have the alternative form of the limit definition of the derivative, and we want to use this definition. F prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. We want to use that to find the derivative of f of x is equal to square root of x plus 1 for a equals 3. So we're looking for f prime of 3. And in this case, it will equal the limit as x approaches 3 of f of x, which we know to be square root of x plus 1, then minus f of 3, which is square root of 3 plus 1, square root of 4, which is 2, all over the quantity x minus 3. Now, since this is we can try to plug in 3 first of all. When we plug in 3, we'll get square root of 4, which is 2 minus 2. We'll get 0. And 3 minus 3 in the denominator means we have the form 0 over 0, which is an indeterminate form. And the way we'd solve this in this case is we would use the conjugate method. So if I go ahead and multiply top and bottom by quantity square root of x plus 1 plus 2 over square root of x plus 1 plus 2, we will get limit as x approaches 3. Square root of x plus 1 times square root of x plus 1 is just x plus 1. And then square the second term minus square the second term, which would be 4. Make sure you square that second term. This is a difference of two squares. First term squared minus second term squared. All over the quantity x minus 3 times square root of x plus 1 plus 2. Now you should notice in the numerator that we get x minus 3, and we also have an x minus 3 factor in the denominator that's going to cancel out with that. We cancel those x minus 3 factors. We're now left with 1 over square root of x plus 1 plus 2. So we have limit as x approaches 3 of 1 over square root of x plus 1 plus 2. At this point we can simply plug and chug, plug in x equals 3, and we'll get 1 over square root of 4, which is 2, plus 2, or 1 over 4. And that does it for these two problems using the limit definition of the derivative and the alternate form of the limit definition of the derivative to find the derivative of a function at a specific point. So that'll do it for this video. We'll go on to the next in the next video.